Okay, in this video we're going to talk a little bit about the differences between a file store, a data store, a database, and a database management system. So you've probably heard all of these terms. A data store is just a place that you can store data, right? And it's roughly a synonym for database. A database is a base of data, right? These are rather generic terms. Data store might be a little bit more generic. But database takes on additional meaning in computer science. When you're talking to a computer scientist and they say database, generally what they're talking about is a database management system. And the management system part is important. It's the part that orchestrates how the data is stored, how it's organized. It has safeguards to prevent anyone else from accessing that data. So it manages the data and has a lot of additional protections that, say, a simple file store does not necessarily have. Okay, and I'm going to show you some of the examples, or some examples of why you might want to use a database instead of a file store. So one of the first reasons you might want to do that is if you have multiple programs that are trying to access some data. Okay, so that's what we're going to do. We're going to start with the simple Python program, and it's going to access data and write data to a file. All right, so we should have probably done this lots of times. So we're just going to call this A, and it's going to write the character A multiple times to a file. Right, and so we'll call this A, and we want to run this one first. Okay, and then we're going to have another program that we start running immediately after this, and we'll call that B, and we'll call that run second or run simultaneously or something like that. Okay, so this is pretty straightforward if you're familiar with Python, where we're just going to have a file name, and this is going to be our storage. So we're just going to call this a data store. All right, so a data store is anything you can store data in, right? So this is a file store, which is specifically a data store that you can store data in, right? So file name, data store dot, and we'll just make up an extension here, my DS, so my data store. Right, so there's a file name. We create our file handle equals open, and what file do we want to open? File name, and how do we want to open this? So for this first one, basically if the file doesn't exist, we just want to create it real quick, and that's what we're doing here. So the first time we run this program, it's going to open the file and then just close it, and that basically has the effect of creating the file if it doesn't exist, or it will overwrite the file if it does exist and has nothing in it. So this will overwrite it with a blank file. So every time we run this program, that's what's going to happen. So we can test this to make sure it's working. Here I'll run Python 3 a run first, and we see a file appears, datastore.myds. It's empty. If I type something into it and save and run the program again, we see it empties the file. All right, so that's good. That's working. And we're only going to do this for our A program. B is not going to do that because A is going to be writing the letter A to this file repeatedly, while our B program is going to be writing the letter B. And we're going to see some of the issues you get into when you allow multiple processes to access a file and specifically write data to a file at the same time. All right, so what do we want to do? Well, we want to write a character to this file, and this is just for demonstration purposes, just to show you why you might consider using a database rather than a file. All right, we have a character A, and then we're going to write that character A 10 times. So for I in range 10, we are going to open a file. File equals open. File name, and we are opening this file for reading. So we want to read the data in. Data equals file.read, and then we'll close our file handle. File.close. All right, and then we'll just print out what we read. Right, so we print out. I'm going to use a formatted string here. So this is the character A, and this is what we read in. And what we read in was this data variable right here. Okay, so we're just printing that out, not a big deal. So we get the data, we print that out, and then we add to that data. So data equals whatever it did before plus our new character. Okay, like I said, character A, we're just adding an A to what was already there. Right? So if there were 2 A's in there, then now data would be 3 A's after this line, and then we're going to write that back into the file. So we're reading the data in, adding something to it, and then writing it back. All right? And for our B program, we're going to change the character. The character is going to be the character B, so we can tell what's happening a little bit. All right. So to make this interesting, to make this work, we have to add some delays. Okay, so the idea is with the delays that the computer program could be doing other work, right? So I'm going to import time and use time.sleep to add delays into this program. All right, but the idea with the delay here, like I said, is time.sleep. We're going to sleep for a certain amount of time, and that's supposed to simulate the computer program doing other things, right? We're making a really tiny little toy program, but in real life you might have very, very large applications that open files and do very complicated things with that data and before they can close the file, right? And if you have a collision just one time, you can lose data, you can overwrite data, and that's what we're going to try to show here. So we're using this time.sleep as just sort of simulating other activity in our program. All right. So how long do we want to sleep? Well, let's have a delay time up here. We'll put this up here. Delay, and we're going to say half a second. All right. So we're going to delay half a second after we've read. So we read in the data from the file, right? We delay half a second. Then we want to open the file for writing again. So we're going to reuse this variable, right? And this is going to be the same file, but this time we're opening it for writing. All right, and something interesting happens here when you open a file for writing. It actually can delete the contents of the file, and then so we're going to pause here as well. We're going to add another time.sleep delay. Okay, so we read in the data, delay half a second, open the file for writing, and when you open the file for writing, remember, it potentially deletes everything until you write file.write, right? Until you have the code file.write. So that's what we're going to do next, file.write. And what are we writing? Well, this is the new data, right? So we took whatever was in the file, the original data, we added our character to it. So if this was 2 A's in the file, if it was just AA, then we added a third A to our data, and then now we're going to write that back into the file. And then we're going to sleep again, and then we're going to close the file. Oh, I forgot the delay there. Delay, time.sleep delay, and then file.close. That closes our file handle. Okay, so this isn't too complicated. This is just creating a file and then opening the file, reading it, adding a character, and writing it. Open the file, read it, add a character, and write it. But we added delays. So that's really all this is, not very complicated. And we run this, and we see the delays, right? So this is what it read. We added a character. So each time through this loop, we're opening the file, reading it, getting the data, adding to the data, then opening the file for writing, and then writing it, and then closing the file handle. All right. So it's very straightforward when you look at it. Just one process, one computer application accessing this data. Right. Well, what if we make a second one? So this is where the trouble might come in. Right. So let's just duplicate this. So we're going to call this B run after. Okay, so we're going to run A and then immediately run B right after that. Okay, so B run after, we still need the file name. We don't want to start out with this. We don't want to create the file if it doesn't exist, because A is handling that. So when we first run A, it's going to wipe out the file and start over, right? We don't need to do that in B. All right, what else? How else is B different? It has a different character. So then we'll call this B there, and then we want the delay here to be about half, right? So 0.25. And what that does is that allows these intervals to be slightly smaller. So while A is taking a long time, hopefully we can get a read and a write in before A finishes a write. And you'll see that you get into some complicated situations and you get data loss. So that's sort of the whole point here. If you have a database, it's really important that you don't have data loss. So if I have multiple applications trying to access a file, then I'm going to potentially run into issues, right? It's not worth having a database if periodically you just lose data, right? That's a critical aspect of a database. You cannot lose data. So I'm demonstrating here again why you might want to use a database instead of a file, and it's generally when you have more than one process writing to a file, the same file. Okay, so we want this delay to be about half of the other one, and I'm going to offset it by another 100th of a second there, just to make sure we don't get in a cycle where they match, right? Because if it's exactly half, then this B will happen every 2 times that A happens, right? So this way it kind of staggers the pattern a little bit. All right, so we read the data. Oh, we also need to print out what we wrote, right? So well, I guess we could just do this read. We're just not going to print out the very last one. We can move the read down to the bottom, and this will be what we wrote instead. Right? And we'll do that for A as well. So I'm going to move this line down to the bottom. All right, so since B is about half of the time, we might want to double up on the number of the letter B that we write. Okay, so that's all we changed. Let's run B by itself, right? And it doesn't stomp out the file, so it should have access to all of these A's that we had from last time. So now we're going to run Python 3 B, run after. And sure enough, we have all of those B's. And it's delaying, but this is going a lot faster than A went. And see, we don't have any data loss. It's pretty evident that there's no data loss, right? We're just adding one character each time, and we see it's pretty consistent. So now what we want to try to do is we're going to run both of these things at the same time. Okay, we run A first, and then run B after. Okay, so as soon as I see one of these letters write, I'm going to run B. Okay, so there's a write, and I run B. Now look at the differences that are occurring here. We have very strange data. This is inconsistent, right? B got one of the A's in there, right? And it didn't even see any other A's. Meanwhile, A got some of the B's in there and then started putting A's. So this is not good. This is not what you want. If you are trying to have consistent, secure, safe data, you don't want something like this to happen. Now, we can dig into why this is happening. All right. So if our B program opens the file, and let's say there's 2 A's in there. So when it gets this data, that has 2 A's. But then we delay, right? So we've added a B, so there were 2 A's and we added a B. Then we delay. In this time of the delay, it could be that program A has written something else. And if it has written something else, when we go to write here, right, we're writing AAB. Well, the A program by this time during this delay period wrote a third A. So the A program thinks it's AAA, and then the B program writes AAB. And so we've lost that third A. You can lose data. So we can run this a couple different times, but that's essentially what's happening here. Let's see if we can get a good one. That one wasn't a very good one. It didn't mix up the data, but you see that it was still wildly different, right? And if we look at the data store, A meanwhile thinks that it's fine. I have all A's in there, and B just smashed over all of that with a series of B. So A has a completely different conception of what the data is, which is not good. All right. Let's see if we can mess with the delay a little bit to try to get it to work out a little bit better. Let's try better time to sleep. Let's do a delay 1 and a delay 2 maybe. So delay 1 and delay 2. And we'll make that one, that first one after the read, a 1. Delay 1 and a delay 2. And we'll make this maybe 20. And we'll make it so, let's see, that's going to be 1.2 seconds, whereas this one runs in 1.5 seconds. So this one's going to be a little bit faster, so we can maybe make that 15 letters instead. All right. So all we're doing is messing with the delays just a little bit, and we're trying to get it to mix up the file reads and writes. So here you see it's very, very odd, right? What we've got here, all right? And it really only takes one anomalous event, right? One event where you do not have secure data, where you do not have data integrity, where you get data loss. Just one of those could potentially ruin the entire data set. So it's incredibly important that you have integrity in your data, right? So this can't happen even once. Now we're playing around with these timings a little bit, to try to get it to break. But the reality is, if you have a file store on a computer and it's running 20, you have two different processes accessing that data, specifically writing data to that file, and they're doing that all day, every day, all the time, for weeks. You're going to eventually get one of these types of situations, and all it takes is one for your data to be destroyed. There's even a scenario where throughout this process, if the data is written at exactly the right time, or if the data is read by one of these programs at the exact right time during the execution of the other, it will read in no data, and you'll literally lose the entire database. So I was playing around with it and trying to see if I could get it to do that. Maybe we'll put delay 2 here. It's not as scientific as I would like, but you get to see the point, right? So hopefully this one will show us something. So there we got some B's in there, but really all of these, when it's still A, are wrong, right? We know that B has written to the database or to the file. We've seen that repeatedly. So the only reason it's holding A is because here, when we read the data, it was all A's. We added another A, and then we paused, and it's during these pauses that B is writing. And if B writes in here, that messes with everything. Right? So then there's B's in the database. But then A writes its A's. So it alternates from B's to A's, B's to A's. But the main problem is there's just disagreement in what should be in the database. Right? So this is a collision. This is a data collision. We're getting the files to clobber one another, right? So this program is rewriting this file every time, and it clobbers over it, right? So anyway, that is a very good reason to choose to use a database. Whenever you have many processes that are going to be accessing, specifically writing data to a database, or to a file, that's when you want to switch over to a database. All right, but there are a lot of other advantages too to a database over just a file. One of the things that the database does is, it organizes the structure in which the data is filed, is saved in the file, right? So databases, generally speaking, store the contents of that database in some file, like we have here, right? It's some file, but they organize it. It might be in a binary tree structure. Various binary tree structures can be very helpful as far as speed for accessing items, speed for storing items in a particular way. And so the way that they're storing that data can be managed by the database management system, and you don't have to worry about it. You just want to access the data, or you want to save some data. You don't have to worry about how it's stored. So that data structure is important for how the database stores it, right? And if you have a database management system, you don't have to worry about that, all right? And if you use just a file, then you have to know how that data is supposed to be organized. You have to know, like we've used CSV files before, which is a comma separated value. If you use something like that, that would be something like Bob would be the first name, and the last name would be Smith, and then you might have an age and something else like an email address, but we're separating all the values with commas, right? And this could be a very, very large data set, lots of different fields, and you might not know what all that data is supposed to be. All right, so if you are accessing the file, then you have to know how it's structured. If you access the database, you don't necessarily. You have to know something about the structure, but not all the nitty-gritty details. And with the file, again, if you get it wrong, somebody else will lose data. So any of the other processes that are accessing your database, if your database just consists of a file and you mess it up, then you've ruined it for everybody else. So that's another thing that the database management system offers. It offers protection around that data for everyone, right? And the data integrity is very important. Like I said, you want your data integrous, right? If you lose any information, it could be catastrophic, right? Another thing a database management system can do is it can store information about the type of data, right? So if you have particular fields of data, like in that comma separated list, I had the number 22, but that could be the string 22 or the number 22. Right? That could be many different things. So your database management system can store information about what type is to be expected in different fields of data, and you don't have to worry about that. So management there is really the key word in database management system. It does a lot of things. Different databases do different things, but the key is they manage the data set so that you don't have to know everything about it, every detail, and get everything right when you're accessing the data. It simplifies it for you, and you can just get data, retrieve data, and then you can set data. So it's nice. Databases are nice. There's a little bit to set up, but you can see where they would be very, very useful. All right. So that's sort of the gist of distinguishing between a file store, a data store, a database, and then the database management system. All right. Hopefully you learned something. Thanks for watching.